Hello, welcome to this discussion video for Math 21. This is part 2 of the discussion video for limits involving infinity. This is the list of items we are solving. In part 1 of the discussion, we finished answering items 1 to 3, and for this video, we'll be starting with item number 4. Again, it is advised for you to try answering these on your own first before proceeding with the video. So for the fourth example, we are asked to find the limit of this function as t goes to 0 from the right. Observe that we have a product of two functions, 1 over t and 1 minus 1 over the square root of 2t plus 1. For the first function, as t goes to 0 from the right, we have 1 over a denominator going to 0 through positive values. And for the second function, at t equals 0, we have 1 minus 1 over 1. The limit of the first function is positive infinity, and the limit of the second function is 0. So, the limit is indeterminate, of type 0 times infinity. Again, if we have an indeterminate form, we need to rewrite the function such that we can determine its limit. For this problem, what we can do is combine the expression in the parentheses into 1 by using the least common denominator, which is the square root of 2t plus 1. So this is equal to the limit of 1 over t times the square root of 2t plus 1 minus 1 all over the square root of 2t plus 1 as t goes to 0 from the right. Take note that if we check its form, it is still indeterminate of type 0 times infinity. So what we do is rationalize the numerator. Okay, so we multiply the fraction by 1 using the conjugate of the numerator, which is the square root of 2t plus 1 plus 1. Multiplying, we have the limit of 1 over t times the numerator becomes 2t plus 1 minus 1 all over the denominator 2t plus 1 plus the square root of 2t plus 1. So the numerator simplifies to 2t only, and we have this expression. Observe that we can cancel t here, so we have the limit of 2 over 2t plus 1 plus the square root of 2t plus 1. We can cancel t because we know that t only approaches 0 and this is not equal to 0. Now in this expression, we can obtain a finite number when we evaluate at 0. This is equal to 2 over 1 plus 1. And therefore, the limit is equal to 1. Let's proceed to number 5. This is the last example for the topic on infinite limits. For this example, we need to find the limit of this function, which involves the greatest integer function as x goes to 2 from the right. So we recall first the definition of the greatest integer function. The greatest integer function of x is equal to n if x is greater than or equal to n but less than n plus 1, where n is the greatest integer less than or equal to x. So since in this item, x approaches 2 from the right, let's take a value very close to the right of 2, say 2.1. The greatest integer that is less than or equal to 2.1 is 2. So we know that the limit of the greatest integer function of x as x goes to 2 from the right is just equal to 2. Let's evaluate the limits of the numerator and denominator separately. Since the limit of the greatest integer function of x is 2, then the limit of the numerator is just 2 minus 1, or this is equal to 1. And the limit of the denominator is equal to 0. But since this is the denominator, we need to determine its behavior as it goes to 0. So take note that the greatest integer function of x minus x goes to 0 through negative values, as x goes to 2 from the right. So we have a constant over a denominator going to 0 through negative values. Therefore, the limit is equal to negative infinity. For item 6, we are solving for the limit of a function as x goes to infinity. This is the first example for the topic limits at infinity. Observe that the limit of the numerator is infinity and the limit of the denominator is also infinity. So we have an indeterminate form of infinity over infinity. Since x is not equal to 0, we can divide both numerator and denominator by the highest power of x in the denominator, which is x cubed. So, this is equal to the limit of 2x cubed minus 6x plus 5 all over 4 plus 7x minus 6x cubed. Times 1 over x cubed over 1 over x cubed. So then this will be equal to the limit of 2 minus 6 over x squared plus 5 over x cubed all over 4 over x cubed plus 7 over x squared minus 6. Now as x goes to positive infinity, note that these terms will all go to 0. So we are left with 2 over negative 6. And therefore, the limit is equal to negative 1/3. For number 7, we have the same form as in the previous example. As z goes to infinity, both numerator and denominator go to infinity. So we have an indeterminate form of infinity over infinity. So we use the same technique, dividing both numerator and denominator by the highest power of z in the denominator, which is z squared. So this is equal to the limit of 4z cubed plus 5 all over 1 minus 2z plus 3z squared times 1 over z squared over 1 over z squared. This becomes the limit of 4z plus 5 over z squared all over 1 over z squared minus 2 over z plus 3. Note that the limit of the numerator 4z plus 5 over z squared as z goes to infinity is positive infinity. And the limit of the denominator as z goes to infinity is just 3. So we have an infinite number over a constant. Therefore, the limit of the given function is positive infinity.